I'm really thrilled to be here and to be a part of this extremely interesting event. I think it's a great segue where Christian left off, actually, because some of the things that I'm going to be talking today about include disruption and how we keep moving and keep adapting and changing with our needs of the future and how digital solutions are a part of that. So just a quick background on GTI Energy. We're a nonprofit R&D organization based out of the Chicago area in the United States. We have over 80 years of deep technical experience and expertise across the whole energy system. And we know that in looking at energy systems, there's not one single solution that's going to help us move forward. We need to advance and scale a lot of integrated technologies, and we need to embrace collaboration throughout the industry that enables our technologies and our solutions to be better, faster, and stronger. So my role with my team is building digital tools as a part of our strategic vision and building decisions around a carbon managed future. And so through a lot of collaboration and research and demonstration scale projects, we commercialize and operationalize this ambition to support low carbon energy systems. I think just yesterday, actually, the UN announced that we reached 8 billion people as a global population. And so in thinking about all those people, sustainability obviously probably comes to mind for many of us. And we need to support growing economies while also supporting deep decarbonization. As economies grow, as more people are on the planet, so does energy demand. And so we need to make sure that people around the globe have access to low cost and low carbon energy systems. So where does digital solutions fit in all that? When we talk about energy systems, and again, Christian touched on some really good points to segue into what I'm going to talk about. We're dealing with some really complex systems, and we need to consider that they're constantly changing. And right now we're under a critical period where we have to make some really significant transitions really quickly. And we have to integrate those solutions into our clean energy systems. And these systems have so many variables involved with changing and dynamic parameters, and we constantly need to understand what's going on and how we integrate them together. And so software automations and digital solutions are really a great tool to aid in reducing the complexity of evaluating these systems and providing better options for future solutions. They can also help us steer in the right direction in terms of the most promising pathways to net zero or just deep decarbonization. We can do a lot with simulating what happens before implementing, and I'll give a few examples of that. And we need to understand that in running these simulations, we look at how it affects the processes, but also we take a look at how it affects the environment, organizations, economies, and most importantly, how it affects people and the communities that they live in. The reality of energy systems is we don't know at all what energy companies of the future will look like. In fact, for all we know, they could kind of look more like big tech companies than energy companies. So we really have to be prepared to shift and pivot, and we have to not be Nokia. We have to continue to reinvent ourselves and rethink how we're operating and push limits and ask questions. Some people might find that uncomfortable, but if you don't face some of those challenges, you might be asking yourself some existential questions going forward. And organizations across any industry are really setting decarbonization goals or making net zero commitments by mid-century or even sooner. And they need data and tools to help them demonstrate that they're meeting those objectives. Right now, even as evident through COP27 that's going on right now, it's not as clear how organizations are making changes and how they can prove that, and that we're going to meet the targets that we've set. So the data needs to support us, and we need to have it available. And today we're doing a lot when looking at this quad chart in that lower left quadrant, and we're doing a lot to automate and optimize the way we operate, but we have new and changing assets in the mix. We need to invite renewables as a source. Hydrogen is coming into play. And we also have really meaningful advancements in technologies like AI and digital tools. So what we need to do is converge all those things together and make bigger, faster advancements in energy transitions and work together to do that. As I already mentioned, in the future, I expect these systems will be increasingly more integrated and will have a lot more players involved as well. And the tools that we design and use have to be flexible enough to change with time, allow interoperability, and also have a growing level of transparency in our data. Traditionally, energy companies are really protective of that data, and I understand why, but we can't make the major advancements and the big disruptions that we need without the data to demonstrate what we're doing. We can realize some of that through building digital twins, especially ones that include spatial accuracy, real-time monitoring, and the appropriate analytical tools to provide meaningful and actionable information. Climate action, sustainability, low carbon initiatives, they're now a business imperative for most organizations. It's no longer aspirational or elective. Like I said, it's almost an existential question at this point. And so we have to move faster than we ever have before. We only have a couple of decades to make meaningful change versus in the past when we made energy transitions, they've happened over generations. Even moving from the horse to the car, like Christian mentioned, that, took a lot of time. But here we are trying to get to net zero carbon emissions by 2050 or sooner. I think digital solutions will be a convergence point where we can really help to shift to whatever that future might look like. These days, organizations need to maintain not only physical infrastructure, but also the data that describes it. Much like physical infrastructure, digital assets need to be updated regularly, checked for quality. Ideally would also be geospatially aligned with physical assets. So, in terms of sustainability, we can use this infrastructure for a very, very long time and potentially for different purposes in the future. If you think about pipelines, right now, pipelines that carry natural gas might carry hydrogen in the future or other renewable molecules. And we need to know what we have and be able to know what we can do with it. This is just a really simplified way of showing you how I like to think about the digital value chain, or really the order of operations you need to follow in order to get to intelligent systems. Because I can tell you, working for a research organization, a lot of companies come to us saying, I want to do AI. Well, what does that mean? Do you really want to do AI, or that's just something that people are talking about? What are your business objectives? What's your value proposition? And what do we need to do to get there? So first, we always need to start out describing our systems, combining static data, event data, even real-time data, whatever else that might include. From there, then we can analyze that information, can create simulations, visualizations, and do all sorts of different analysis. And then once we do all that, we ideally would have some form of actionable information that we can feed into decision support systems or even other prescriptive tools at some point. But we kind of need to make sure that we're going in the right order to be able to support some of these tools. You don't just jump to doing AI without having any data. I'm going to talk about several examples of tools that we've been building using IoT. So I kind of wanted to describe how I'm thinking about IoT. I think about it as an ecosystem, and just like any ecosystem, conditions change all the time and it can't stay static forever. So we have to be ready to shift and change the way that we're operating at any point in time. So ideally, it's based on open standards. I mean, look at how much we can do just because communication protocols like Bluetooth, Wi-Fi, LoRaWAN, and other standards exist. If we didn't have those standards, I think we'd have a really hard time effectively deploying some of these technologies, especially some of the ones that I'm going to talk about. According to IHS, which is now S&P Global, they estimated that there are expected to be over 75 billion IoT devices by 2025. I think that might be a little bit high just because that estimate was made before COVID. And I think COVID actually created both supply and demand shortages for IoT technologies. But we're still talking about a scale of tens of billions of devices being actively out there in the world. So we need to make sure that as we're implementing these tools, that we're doing it in a way that encourages interoperability. And I guess that leads into my next slide, that I've reduced all the challenges that we see down to two, because these are the two biggest challenges that I see most frequently. Scalability and interoperability. On the scalability side, I see so many technologies, even some that we've developed, that are just unable to get out of a pilot phase. They're just perpetually being tested at a certain scale and can't be deployed outside of that. In terms of interoperability, there are a lot of tools being built today, and I don't think I have to tell anybody here that, but just thinking about your applications on your phone or the types of Bluetooth speakers or whatever you use these days, these things have to work with the technology that we have. If you think about all the time and dollars that organizations have invested in implementing some of these tools, they don't want to just throw that stuff out the window every time a new tool comes to the market. So we have to make these things work together. Otherwise, we'll never create the type of impact that we want to make. So I want to go into a few examples, and starting out with quick wins. So ideally, it's great to start out with some quick wins. And I love talking about quick wins because they're quick and they're wins. But I would encourage anyone, if I go too quickly through these, to follow up with questions or follow up with me after the event. For starters, this is a tool that I thought would be a quick win. It ended up not being so quick, but just had that high probability of turning into a win. So we kept going with it. But it was still, we deployed this tool in only a few months. But we just built this tool called HYPEC, the Hydrogen Production Emissions Calculator. There's actually a nice tech talk on this tool that should be on our GTI Energy website if you want to learn more about the specifics. But this tool takes a really complex model, the GREET model in this case, and reduces it in an easier to use public tool to help estimate carbon intensity of hydrogen production for a few of the early stage technologies. So in this case, we were able to partner with subject matter experts in our organization, with the software developers in our organization, and produce a super useful tool in just a few months. And it's publicly available on our website. So I'd encourage you to check it out. Another quick win, this was a quick win. We had lots of data loggers in the field, and on this project, we were going through an extremely laborious manual process to get the data from the field to the engineers back in the office. And so we went from having to wait 3 days to get the data to it being available the following morning. And we built a dashboard and an app so the engineers could access the information in a more user-friendly way instead of having to sort through an Excel spreadsheet and figure out what to do with it. And the data was 3 days old by the time that they saw it. And the next example is pretty similar, but we have vehicle monitoring for natural gas vehicles. We have sensors that collect different data on each of these vehicles. We transmitted encrypted data over just standard cellular networks, and then created different data pipelines in Microsoft Azure to give nearly real-time monitoring of these sensors. And this was all just by introducing standard automation tools and not even anything that's extremely complex. Well, I just want to pause for a second here, though, to say that in developing these quick wins, we learned a lot. And we learned that you don't need to transmit everything to the cloud. So as you're collecting data on these sensors, and these, especially the more sensors you have, transmitting, storing, and analyzing lots of data in the cloud can get really expensive really quickly. So we learned that you don't need to send all the raw data. For many of our field sensors, we were able to build in edge analytics and send only the important or relevant information. I'll give an example of that in just a second. but maybe the sensors only send data that indicate abnormal operating conditions, or if different anomalies or situations are flagged. Or in some cases, we built machine learning tools to identify very specific signatures in the data and transmit only that analyzed data to the database. And then even once it gets to a database, we tend to do layers of additional analytics on top of that, even before presenting it to the end user. So that ended up helping us to save money over time in transmitting all this information. So a few ways we're deploying some of these sensors include various methane monitoring tools. Methane is a very potent greenhouse gas, and to get to a decarbonized future, we really need to work globally to reduce methane emissions while also supporting those that rely on natural gas as a source of energy. I'll go into some specific examples about how we're improving methane emissions monitoring and supporting decarbonization. So this first example is monitoring emissions and increasing safety by deploying a couple different sensors to support natural gas pipeline monitoring. We built sensors that monitor these pipelines and also vehicles like excavators that might operate close to pipelines. So it can send alerts when risks are identified. So for the excavators, we built algorithms to identify when the excavators were digging by way of vibration, acoustic, and mostly other motion-based sensors. And when the excavators were digging too close to a pipeline, alerts were sent to the operator and also any other people that needed to know in real time. And similarly, we had sensors installed on the pipelines to characterize different signal patterns locally, only transmitting the significant events. So that was doing some of that edge analytics. And we also differentiated those events. So we could identify indications that a leak was occurring, or if there was pipe stress identified, things like that. So all of this information was also displayed in a real-time geospatial dashboard. We're also building more distributed sensor networks to monitor emissions across oil and gas production regions that could really change the way that we detect and even eventually predict and mitigate methane emissions, and especially unintended emissions. We're in a pilot phase right now for this project, but we built a digital twin of the test region, and that included atmospheric models, emissions data, geospatial mapping, and other analytics. And we simulated leaks to try to understand how we could use that data to pinpoint where they were coming from on a large scale. So we did a lot of simulation to help identify, it also helped us identify the optimized placement for these sensors in the field. So we hope that this can result in broader monitoring programs at larger scales. Like I said, right now it's just at a pilot scale, but let's hope that we can scale it up into a larger scale and result in actionable data moving forward to help reduce emissions due to oil and gas production. All the work that we do related to methane emissions mitigation will hopefully lead to broader and more transparent data sharing. We hope that any interested stakeholder, whether it's governments or academia or just a concerned citizen maybe, can access the information that they need to understand what their role could be in supporting a more sustainable world. So our Veritas initiative is kind of a good example of this. We're developing a standardized approach to measuring and verifying methane emissions intensities as a flexible and foundational tool. And with that, we hope to encourage better methane accounting and collaborate with other initiatives globally to make it easier to understand how we can reduce global methane emissions at a much faster rate than we are right now. The last two examples I have for you are a little bit more global in nature, so I thought it would be worth mentioning them. Our gas project converts coal, biomass, and waste to liquid fuels and chemicals, and also supports power generation. It's a much more efficient and cheaper gasification process, and also uses novel materials that hadn't been really used before. So what we did is we used high-speed cameras to test and redefine our input parameters iteratively, and simulated and predicted and simulated and predicted. And then we used Aspen Plus to build the model, but wrote additional code on top of that to analyze every single foot of pipe with about 24,000 data points, and then plugged all that back to into the model. So like I said, this led to improved efficiency, significantly reduced costs. And right now we have a demonstration scale site running in China. And finally, I wanted to give an example of other broad programs that we're doing. We have programs like our Open Hydrogen Initiative. Hydrogen has emerged as a promising low carbon alternative for hard to decarbonize sectors, but the success and acceptance of hydrogen will require understanding the fuel's carbon intensity. So this initiative combines an international cohort of energy sector professionals to build consistent, transparent, and technical measurement protocols for hydrogen production at the asset level or facility level. And so we really hope that this initiative will create a market to support globally traded hydrogen, and will build the useful digital tools to facilitate that as well. That's all I have for you today. I wanted to point out to you that most everything that I talked about today required lots of collaboration, really bold thinking across many different stakeholder groups. And I would love to hear from you on any questions that you have, but also welcome thoughts for future collaboration also. Thank you so much.
Thank you, Shannon, for your great and insightful presentation. I hope that you can see me now on the screen. Good. I was really listening to your presentation, and it was great for me because actually you was touching the area which where I'm working, and we are with our company for 20 years already, which is data processing in kind of great speeds and great masses online. So some of the questions which I collected during the presentation, and now we'll be touching that. You see at the GTI that GTI Energy that everything needs to move at unprecedented pace, and new solutions are just being a need, not just an option, to reach the sustainability goals. The digital solutions are key element of that. So in which areas you see current digital vendors still lagging behind most?
That's a really great question. I would say that there's a few areas, but the biggest one I think is there's a tendency to not have open collaboration. And I think that there's starting to be a shift to that. So a lot of the vendors that we work with, we do see changes, but there's a drive to have these proprietary systems that have really exclusive types of workflows, and the data is stored in a really private database and needs to be interpreted before it can be used anywhere else. So that all that does is hinder the ability to make use of those tools and those systems. But I do see a shift starting. So I think that, I would encourage, as we're developing new tools and we need to move faster, that we keep an open mind about how the technologies that we build work together and how we can create systems that allow that data to interact. Because when you have data, and I think anybody that deals with databases understands this, but when you have data that's in a lot of different silos, it makes it a lot more challenging to bring it together and make use of it in a real way. So being able to take the data, even if it is from various databases, but it works better together. Those are key issues that I think are on trend to being solved, but we're not moving fast enough, in my opinion.
So the integration is the key, where you would like to see the vendors getting up in their speed.
Yes.
Good, thank you. I have another question here from the field. What kind of results have you witnessed concerning how companies have been able to decrease energy consumption with digital twins?
That is a really great question. So I think we're just at the beginning of being able to see that. The biggest way that I see that isn't really on the energy consumption, but it's operating more efficiently. So with digital twins, a lot of people have been able to identify areas where, wow, we didn't know we were using this much energy in this area. We don't need to be, so let's scale back. Or wow, why are these systems running all night? They don't need to be running all night. Let's turn them off during the nighttime hours. So it exposes and reveals a lot more information about how our systems are operating. And that's, at a facility scale, but it can be at an even larger scale as well. So if you think about emissions, some of these organizations don't know that they're emitting carbon, CO2, methane, other critical, elements that are getting out into the atmosphere. If they knew, they would do something about it. So what these digital twins reveal is having that real-time feedback loop and understanding where the problems are occurring is really where organizations are able to make change. Those are the biggest ways that I've seen, and efficiency and just awareness and transparency about how their systems are operating.
And could it be more than 50% or less than 50% or much more, much less?
That I wouldn't be able to put a number on, but I will say that even in just our demonstration scale sites, at times we will see trends toward abnormal operating conditions. And sometimes these things happen so slowly that they're not noticeable. But when you see that, these things are leaking, especially gases and fuels that are expensive, you want to stop that as soon as possible. So I would say that I couldn't put a number on it, but it's definitely significant. Absolutely significant.
You mentioned some great pilots paving the way already. What do you expect in the future? What kind of number of new pilots you are expecting in coming, let's say, 2-5 years, and how big would be the growth, the kind of exponential growth of these pilots, for instance, for you?
Yes,
your expectation?
That's a really great question too. So I think that pilots are the key to getting technologies out and actually being used, because what we learn a lot with pilot programs is whether not only do the technologies work, but can organizations actually use them? So we have technologies that we've built and we realize, hey, we get all this data from these pilot projects, and what are we supposed to do with it? I don't know what this means. I have to hire someone to interpret it. I have to get a statistician to tell me whether it's statistically significant. So being able to take from the pilot scale, present the information in the appropriate way, really saves a lot of time in terms of implementing these technologies in a commercial domain. So what I would say is, pilots are the way to go, but you don't want to get stuck in the pilot phase. I do see them increasing exponentially, especially in terms of the climate challenges that we're facing today, and getting things out into the market. And the ways that we're doing that is by a lot of collaboration. And so I know I'm kind of repeating myself again, but working with partners and working with others that might already have sites that we can use or technologies that we can deploy, that's kind of the way that we've been successful in those spaces.
Yeah, I share the vision that the collaboration is great. And I see also Sonia. So we are running out of time, so we should end, or we have time for one last question.
No, unfortunately, we need to move on now. Shannon, thank you very much for your presentation. It was great. And as aforementioned, we will send all the questions. You can submit them in the chat or also in the LinkedIn group or directly to Ni's email address, which is posted in the chat. And we will make sure that they reach Shannon.
Thank you so much.
Thank you as well.